I'm going to talk about a particular product or tool that I built actually. And I'm going to show you how I built it very quickly using Google Tools. And the idea is to tell you or inspire you to do something like this yourself. And it's very easy to do. Okay. I've been doing a bunch of stuff in and around Google Cloud, a lot of certification stuff. I'm creating some course content for Google. Been doing a bunch of stuff around their certifications, again, helping with creating some of the certification questions and all. So this tool that I built, it started around September 2023 when Google gave us a bunch of credits and said, hey, here's some credits for generative AI, go do whatever you want. And I was like, okay, I don't know much about generative AI. And since we are starting with technology as a starting point, I need to understand that, okay? So my first goal was to get a sense of what generative AI was. And what I'm going to do now is to not get into the details, but I'm going to give you an overview of what it is for those who might not be familiar so that you can use that idea to build products and tools yourself. Okay. So how does this work? The starting point for generative AI is to be having a large amount of data. The data might come from databases, it might come from news articles, it might come from customer conversations, it might be transcriptions of videos, it might be financial articles, annual reports, any of this, right? You take all of this text and then you put it into an algorithm without doing a lot of data manipulation, right? So it's very easy. You take all of this data without any pre-processing, dump it into an algorithm, and the goal of the algorithm is to come up with a representation of that data, right? So as with a lot of other things that we have in the real world, there is a system, there is a universe, right? And we have a model of the world where the sun is at the center, we are revolving around it, it's also rotating. And that model of the world gives us the ability to predict what is going to happen, right? We can think or we can describe what has already happened and also predict what is going to happen, right? So a good model is a representation of a system based on which we can understand that model, understand the system one, and also make predictions about what will happen, right? So for example, with the model of the solar system, we are able to predict when there's going to be winter and summer and when it's going to rain, when exactly at what minute the sun is going to rise tomorrow and when it's going to set tomorrow at a particular location in the world, right? So it gives us a huge amount of power to do that, right? So a good model will therefore have a predictive capability, right? And it has to be able to represent that model sufficiently well to be able to make those predictions. Okay, so the way this with generative AI, the way it works is, since in this case we are talking about what are called language models, right? So language model is about language. So we've got all these words. So let's take a very simple use case where we've got a bunch of words, right? In English, there are hundreds of thousands of words. Let's take a few of them and see how a model like this might work. Again, remember, it's an analogy, not exactly how it works, but it's sufficient to understand enough to build tools based on it. Okay, so you've got all these words, and in the beginning, there are no relationships among them. Okay, it's not connected in any way. The first time the model encounters something that says, in Paris, France's capital, the president said, right? So here you have the idea of Paris, France, capital together, and the model somehow represents a connection between this, right? It says, okay, there is some connectivity between the idea of Paris, France, and capital, but it's not very strong. When the next time it encounters something like, hey, I landed at Charles de Gaulle Airport in Paris and France's capital, again, the idea of Paris, France, capital is connected, right? And now that association becomes stronger. And the next time it reads, say, a sports article that says, the finals will be played in France's capital. Anybody planning to visit Paris? Again, France, capital, Paris. And so this relationship becomes stronger and stronger, right? And this can be mathematically represented. The frequency of words, the interconnections between words can all be mathematically represented by weights. Okay, so in this case, again, an analogous representation. The words Paris, France, and capital start off with no connection. Then the weight that connects them increases little by little. Okay. And at the end of it, we have all these connections and weights that represent the language, and all of that is the model at the end, right? So you take all the data, run it through the algorithm, get this model that represents the data. What is in that model? Large set of numbers. Okay, so very important to remember that at the end of doing the processing, we no more have the data. We only have numbers that represent the relationships among them in some way. Okay, there's a lot to this. There's an entire field of study to this, but this is a very simple overview of what you have. Okay, very important to note here is that at the end of creating this model, we do not have the input data. So we started with maybe gigabytes and terabytes of data and news articles, which is all plain English, right? You go through the processing and what you end up with is just numbers. So there's no way we have got access to the original text. So this is different from how you would do like a Google search, or rather on your browser. If you do a search, right? If you type for some word that you want to find on the browser page, it is going through the text, finding that exact match. We don't have that option. Okay. So in generative AI, we are working with numbers that represent the original data. That's it. Now, this has some significant advantages, but also some disadvantages. Okay. One of the advantages is obviously that the size of the model is very small, right? So if you take the solar system is huge, but our model that represents it is very small, right? So we can quickly process decisions about, say, when will the sun rise tomorrow? Will there be a storm tomorrow? And therefore, based on that, can planes take off? Can we reschedule? Do we need to reschedule a meeting based on whether planes take off, right? So all our decisions can be made based on a good model, right? And the faster we are able to make the decisions, it's good. So instead of processing terabytes of data every time we want to make a decision, we can ask this model, which is just numbers and which will be boiled down to a few maybe gigabytes. Okay, so it's much faster, easier to move around, easier to send around, easier to make predictions based on it because there is less calculations. Okay, so we have this representation now of all these words, hundreds of thousands of words and their connections. Okay. Now, if I ask the question, what is the capital of France? This is considered as input to the model. Okay. So the words, what is the capital of France, are 6 words that are an input to this model. Okay. And this is called the context. Right? So there are 6 words in this context. We send it into the model, and my question to you would be, how would you continue a conversation that starts like this? Okay. Now you have to assume here that you don't know English or you don't know the answer to this. Okay. Go with the assumption you don't know anything, no English, no answer. You're trying to figure out what is the answer based on a set of knowledge. Okay. So how would you process this if you were doing it as a machine or somebody who didn't know this answer? If you had to continue the sentence, you're looking for the next word that will come after this. Okay. What is the next word? It's a choice you have to make out of all the words that you have in your dictionary. Right? So these are all possible words that you can choose for the next continuation. How would you rank what is the best one? You rank it in some way and then you assign a probability. Okay, so the probability says among the hundreds of thousands of words, the highest probability words that could continue in this, this sentence would be one of Paris or the or France or among. So one of the way to respond to what is the capital of France could be among the countries of the world of which France is one, Paris is the capital, right? But that would be too roundabout and convoluted. Instead, we can just maybe use one of the words that have a higher probability, right? So you could probably start with Paris, or maybe you can start with the. In this example, let us say I choose among the 2 that are available, I chose the first word, which is the. Which is Paris. Okay. So now the new context, the whole input to this LLM is, what is the capital of France? Paris. Okay, so now the context increases from 6 words to 6 plus 1, 7 words. Right. So now you again go through this. What is the capital of France? And remember that in the model that we have, capital France and Paris are connected. Right. So given capital in France is there, it chooses, okay, the next probable one is probably Paris. Now this model is built on all the words, including English grammar. Right. So there'll be a lot of words where we continue this sentence in normal English grammar. So given that we say Paris, what is the next possible word? If you can guess what is the next possible word, put it in the chat. So the new context is, what is the capital of France? Paris. What would be the next word? It would be is. Yeah. So exactly. Yeah. Somebody's given it already in the chat. Can you guess the next words and the next word also? So the new context now is, what is the capital of France? Paris is. Okay. After this, what would be the next word now? If based on English grammar and everything, Michael, that's exactly it. Paris is the next one. This is a little longer to type, but if you have to complete this sentence now, what is the capital of France? Paris is the capital of France. Does that make sense? Yeah, exactly, Jennifer. Yeah. So the idea is, the way LLMs work is to look at this body of knowledge, which has been condensed into just numbers that represent that body of knowledge, and then try to predict word after word after word. Now, in reality, we don't go word after word after word, because it takes too much computing power, which is why, if you see the older Nokia phones and all, once you type some word, it will try to predict the next word. Okay, so that uses a different technology where it links maybe about 2 or 3 words past using something called trigrams or n-grams. But to do that processing is a lot of effort. And if you had to do this for hundreds of thousands of words, it's huge amount of computing, which means that not only will it take a lot of cost, it'll also take a lot of time. And we don't want the next word prediction to come after 2-3 minutes or a few hours. We want it to be quick. So newer technologies called transformers parallelize this, right? Where simultaneously it is looking for, while it's already looking for the next word, it's already seen what could be the words following that, right? So very quickly it is able to do that. But the core idea is that it behaves like a sophisticated autocomplete. You're trying to look to autocomplete the word one after the other. Okay. And in a previous talk that I'd done elsewhere, I'd shown how, starting from random mathematics and using the frequency distribution of English characters, like the letter E appears way more than the letter Q. The letter Q, if it appears, immediately U will appear, right? Mostly. So using basic frequency distributions like that, like how often does it appear in English language, you can actually randomize this and come up with meaningful sentences. It is very interesting how it is able to do that with pure mathematics. Okay? And that's essentially what it does. Predict the next word one after the other based on what it has already understood. Now, the interesting thing is, this applies to any language. Okay, so if I gave you the initial context, instead of what is the capital of France, which was the initial context, let us say I gave you the initial context as roses are red, in a model that understands poetry. So here is a model that has understood a lot of poetry, come up with all the numbers that represent the model, and now we give it the initial words, roses are red. Okay. Now, how will it continue this? I think you know how this will end. It will be something like violets are blue. Exactly, Jennifer. Yeah. It will be violets are blue something and then something else. Okay. So you can apply this to any language, including code. In code, for example, if I take, say, JavaScript, right? If I say for var I equal to 0, what would be the next character? It will be a semicolon. After that, it will be a conditional statement. After that, it will be an incremental statement, right? So for any language, if you go one by one, predicting what letter or what character or what term would come next, you will be able to predict or you will be able to come up with meaningful language, right? So in this case, for example, it will complete this. So for any input language, we can follow this process and get results like this that are completed the same way ChatGPT and all completes what you ask. ChatGPT, Gemini, Bard, the underlying technology is similar to this. Okay. So now I have a basic understanding of how LLMs work, right? I have a representation of the model. Now, if I ask it a question, it will try to complete it. So I was looking for, use cases where I can implement this. So one of the things I quickly did at that time was to find out about model numbers. Why? Because at that time I was looking to buy monitors, and these monitors had these codes like 64 RMM, whatever, right? And I was like, I had no clue what this was. I thought it didn't matter to me. But the more I researched, I understood that this also is a language. Okay, so if it is 6, it means that it was built in the year 2016. If it has got U in it, it means that it's some Ultra HD, or Q is QHD or something like that, right? So this also is a grammar. So very quickly, I created this website. I've shut it down right now, but I used it then to find out what do these model numbers mean. So when I gave it a model number like XR659 or whatever, it, without any prompting, without any other input to it, it is able to get me results by looking at this. Okay, and I tried this for multiple models, and I finally bought a LG monitor that is fit my MacBook and all of that, and it is working very well, right? So this was a very quick use case that I did and submitted as part of the hackathon. But then I thought, that was a one-time off thing. What else can I build? What else can I build that would be really useful? That would be useful for me for the long term, something that I would use every day. So I looked around, and one of the things I struggle with is command line arguments, right? Working in the cloud and working on the Unix command line or Windows command line, you've got all these commands to run, and I can't for the life of me remember what these commands are, right? How do you find files within the subdirectories that match a particular pattern? I don't want to remember. I don't care to remember. In fact, there is this Sherlock Holmes quote where Dr. Watson is asking him about memory, and Sherlock Holmes replies that your brain is like a room that has got limited capacity. When something goes in, something has to go out, which is why you will also notice that as you grow older, you start forgetting things because you've reached the limit of your mental room, right? Your brain room has a limit, reaches capacity. So if I ask, I've got a little baby girl. If I asked her what she ate 3 weeks ago for breakfast, she'll remember. Why? Because her brain room is not filled yet, right? Every detail matters to her. But if I asked you what you had for lunch yesterday, you would struggle to remember what it is, right? So as the as I'm having to deal with more and more commands, I'm like, I don't want to remember all of this, right? And mostly everything that I do now is on the command line, right? I'm sitting here somewhere, but my machine is in Iowa, or London, or Tokyo, or Mumbai, right? And I remote into it, run commands on the command line. On my local machine, I'm doing the same thing. And there are commands for everything now, right? Almost everything is done on the command line. Even Google Cloud has about 200, 250 products within Google Cloud. That has a top level command called gcloud, a sub command for each of these products. And each of them have sub commands, which have options and configurations and all of that. And I'm like, I can't remember, and I don't want to remember. And that is just gcloud. Then there is other clouds that you might be working on, AWS and Azure and Oracle and all those others. And if you ever have been with the Compute Native Foundation, they've got Kubernetes and Docker and Istio, and everything has its own command line, right? So it's a huge influx, a deluge of commands and command lines, and the less I remember, the better. So I was like, okay, can I generate commands for me without me having to remember it? Okay, so I'm going to shift you to the this tool called AI Studio that Google has. Okay, so what I have is this thing. Okay, so I'm just going to go here to AI Studio and then say, give me the command to delete a pod. Okay, I run that, and it gives me a whole bunch of stuff. Okay, now I obviously don't want all these details. I just want only the command. So what can you do? The original, this was my original input, right? Give me the command to delete a pod. I'm going to modify it a little to say, command to delete a pod, but give me only the command without any explanation or description. Okay, so let me do that now, and it immediately gives me that. Okay, now here is what I want you to note. I have an idea that I want to generate commands which would make me way more productive on the command line. From idea to proof of concept, how much time did it take? Seconds, right? This call itself, I think it returned in about 0.7 seconds. Yeah, in 0.7 seconds, I got my answer that this would work. Okay, this is wonderful. So in a matter of seconds, I have validated that I can generate commands. So now my next thing would be, how would I take this and build it into the command line? I don't want to come to the browser each time and do this all the time. Okay, Bishal, just hold on. I'll show you how you can do that. Okay. In this itself, there is a get code. So there is code that you can copy paste for Python and JavaScript and all of that. There used to be also the code to get for the bash script. And if you still want it, it is on the website. It's just not here. So I took that code, I copy pasted that into my command line. Okay. So I'm just going to show you that I already have this in this code called run.sh. Okay, so for this you need to have an API key. The API key is freely available from Google. You can get it. Yeah, and then I've got this prompt that says give me Unix command to find all. So it's a long complex English text that I have written. Yeah, and then this is a code that I copied from Google, from the AI Studio provided by Google, where it says we are going to post this to this API endpoint with this key, and I'm going to pass in my prompt as a text. Okay, that's it. So let me just run it now. It should be all good. Okay, so this is a prompt that I'm giving it. It goes to the backend, comes back with the answer. Now the whole answer is actually a long JSON. I don't want all of this. Okay, so I run it through what is called JQ. JQ is for querying JSON, where I'm saying pull out all the candidates within that content, within that paths, within that text. Okay, and it has given me exactly what I want over here. All right, now again, what I want you to know, I have gone from proof of concept, idea to proof of concept, seconds. Proof of concept to working code, minutes. That's it. Okay, so I ran this and I figured out this is so powerful because I started using this regularly and I'm saving so many hours per day. Because usually what you do is you'll go to a browser, you'll search, you'll look at all the links, you'll copy it, you'll read through it, you'll find out something that works and then bring it back. That's what you would normally do. And with this, I was saving like hours in a day, just having to avoid looking for things. So here is a demo of what I built, where I'm saying gen command, this is a command line I wrote finally, right? And Bishal, I'll show you this earlier, where I'm saying find text files that contain the word hello, and it gives me multiple options, right? And remember, I have done nothing. I don't have a database of these commands. I'm just asking the Google Gemini. Okay. Jonathan, I will share the source code. Okay. Then I was using Palm. Here I'm using Gemini. I can run this with G Cloud. I can ask questions on AWS. After this, I'm going to ask about Azure. All of this is coming from the LLM with no effort from me. My effort has basically been to just ask this question, right? Azure, create a VM instance. kubectl delete, and see how this is doing it. kubectl delete a pod named hello in namespace, and it's integrated that into the answer response. Okay, so it's not giving a preset answer, and this is all running live, right? This is not a video that I'm running. This is the reason that takes, you can see the lag. I've added a 3-4 seconds lag just so that it doesn't go fast, but it's hitting the web server, coming back with these answers. Yeah, very powerful, done in a matter of minutes. I can ask it in French. Here I've done it. I've asked something for nmap. I've asked je veux ajouter un utilisateur on group, which is, how do I add a user to a group. Here I'm asking Spanish, buscar archivos en cualquier subdirectorio cuyos, all that. Okay, it just works. English, Spanish, Portuguese, French, just automatic, nothing for me to do. I also added a new feature where I say explain a command to me, right? Not only list the commands, but also explain it to me, and it just works. You can do this. You can do this yourself, right? Where I mean, you might want to do this yourself, where you've seen a command, but you don't know how this actually works. Yeah. So let me show you where the code is. I'm going to share these links with you later on, so don't bother about copying these links right now. Okay. So this code, I started off writing a shell script, where the shell script used the same code that I showed you, but I added some bells and whistles. Right. This is the main part of the code. But then I added some bells and whistles where I'm saying, okay, I want the command for say Debian or Windows or Unix or something like that, right? And how many results do I want? How do I set things like temperature and top K and top P and all? There are inputs to the LLM itself. And I did that, and it is all open source. You can use it. If you want, I would recommend that you rewrite it yourself, though, because I haven't maintained this for a while. And then I rewrote it in Go. Because with Bash and shell script, you can't run it on Windows, right? It's a little roundabout to do it. And Go, on the other hand, I can build it for multiple platforms. And what I did then, I realized more and more people are using it, that I created this thing online. Okay, so there is online, and there's also a corresponding command line option, where if you go to gencommand.com, if you just go to gencommand.com, right? Let me see if I can put that link, or somebody else if you can put it. Let me just do it myself. Yeah, you can go use this at any time to find out the answers to this. And today I think there are about some 200 signed users, right? Because this thing is slightly costly, running LM slightly costly. So I'm not able to give like unlimited use. It's free. It's free, at least for now, right? As long as Google can give me some credits, I'll keep it free. But after that, we'll see. But again, the core thing that I want to convey is how easy it is to build these tools. Okay, somebody's asked in the thing, what about OpenAI? You could build this with those also, right? Anything like this. If you have an idea, try it out, run it. It'd be easy to build this out. Okay. Now, just in the interest of time, I'm going to go back to these, and I'm just going to skip the next few slides. I usually have these slides only if the internet doesn't work, right? And I'm not able to do a live demo. But it's the same thing. I'm just showing how I went through that process. I got the code, I copied it, I put some parameters, and I run it. Okay. A couple of things that you can control is within how much probability do you want options, right? So for example, if you're trying to continue, it's raining cats and you're trying to come up with the next word, you've got all the hundreds of thousands of words that you could potentially use, right? But you're saying, hey, I don't want all of that. Just give me the words that add up to a probability of 0.7. So you're reducing the amount of processing the system has to do, which would potentially make it faster, also maybe better. Top K chooses a number which says it's not choosing a probability, but among the top 4 options, give me any one, right? So remember here, you're making a probabilistic approach, which also means that you might at times end up with the wrong next word and the wrong next word and all of that. So that's a possibility you'll have to deal with, okay? And then there is also this idea of temperature, where the greater the temperature, the more variation in the output. And in normal English, more variation if there's lateral cross connections and all. Typically, it's an idea connected with creativity. Now, I won't get into the philosophy of that right now, but typically, more temperature that you set, it's a variable that you can set into the input, you get greater variations in the output. Okay. You also have a way to block certain kinds of content, like if it is racial or sexually explicit or dangerous, right? But you have to be careful about this. For example, in commands, when I used to run, how do I kill a process? Initially, Gemini responded, Palm and Gemini responded, oh, we are not going to tell you that. It's a dangerous, something killing is wrong, right? Something like that. So it said it's an unsafe response and refused to give me an answer. So I then set the dangerous content level to block none, like don't block anything, because since my prompt is very specific for commands, it's not going to give you something like how to build a pipe bomb or how to, commit suicide. It's not going to do anything like that. So I lowered the safety setting on that, but I keep some of the others, I just don't want certain bad things to happen. So here again, just sharing the code, how I did in shell script and then in Golang. If you understand Golang, the code is again open source. I will still give you that. Okay. And what I've done is with gencommand.com and the corresponding command line, I'm able to route it to multiple LLMs, right? So that's what I showed you, the browser. And in the backend, what I'm doing on Google Cloud is to take that request, whether it comes from the website or whether it comes from the command line, route it to a Google Cloud function, which then routes it to the model that you ask for. So maybe somebody says, I'm comfortable with Gemini. Somebody says, okay, I'm not comfortable with Gemini. Then I want to run my own, or if I host a custom model for you, you can do that, right? So things like that, I've expanded the use, or rather, the things that would make it useful for people, right? While continuing to be extremely productive. And with that, I think I'm about on time. I will share these links later in the chat. You can try it out, or why don't I just do that right now? Yeah. So these are the links. If you want to try out this tool, you can register there, and searching is on that page. And I think I've got a few minutes for questions. So I'm going to look at the chat and answer questions there. I have written an article about how I built this. So if you want to build something like this yourself, check out this Medium article. Yeah. And the two code sources are here. Okay, so the GitHub. Now, this is not the one that is publicly available on gencommand.com. This is a previous version, right? So it's for you to review the code. It is not what is currently working, right? I've added a lot of features since, that is not public because there are API keys and all that still inside that. Okay, that's me. If you need to connect with me later on, this is my name. And do try it out. I think it's a very productive, useful tool. Okay, and if there are, I'm just going to look at questions in the chat. If there are any, I'll answer, and after 2 minutes, I'll hand it back to the host. Okay. Bishal asks, how is it different from OpenAI and other tools out there? The underlying thing is the same. Gemini, Gemma, all of these, right? Frontier, foundational models, they're all the same. This is an application built on top of that. In this case, I'm routing it to Gemini and Palm and Gemini Flash and all. You could route it to Mistral and Claude and OpenAI and all of that, right? There's no problem. It works very similarly. Eritance is very good tool. How about the security? It's safe to use. What is your point on safety? My answer is yes, because the prompt is controlled to just being about commands. So it's not giving again, about how to build a pipe bomb or things like that. At the same time, if the question is about security, in the tool that I've built, I give you the option to say, don't store my searches. Yeah. So that part is not built yet, but I'm in the process of building that. But even otherwise, the model themselves, because I route it through Google, except for one Palm model, all the others go through Google Cloud, right? The Palm model, one of them goes through AI Studio. All of them, the contract between me and Google in this case is that Google will not retain that for training. So on that part, that's the contract with Google. Jennifer asked, how are you making a living? How to monetize? I've got a bunch of ideas on this. I'm building couple of tools also, right? So far, I've not monetized this. It is a free tool. I find it's productive. I'm talking about it because I think it'll inspire people to build other tools like this. Yeah. But I get the feeling that I will eventually have to monetize it because running LLMs and models are not cheap, right? And once my credits with Google runs out, it's going to hit my pocket. And if like tens of thousands, hundreds of thousands of people, they're using it, I can't afford it, right? So at that point, I think if it's that valuable, of course, people will be willing to pay for it, right? Right now, I don't have anything, it's free. H asks how to use AI to predict stock market prices. I'm not I think there are, people in all these big investment companies who are doing this. I don't have that. And I would recommend things like this are very fickle because if there is a model that represents the real world, it has to be consistent, right? So the idea about the sun rising at a certain time, it's consistent because it follows laws of physics. But things like stock market are not driven by laws of physics, right? It is driven by hype, it is driven by emotion, which means that all the data could point to something increasing in price, but maybe there's some random, who's that, deep FN value or roaring kitty who comes and posts some meme about that gamer interest. Right? I don't know if you have been following what has happened with the GameStop stock, right? He posted one meme and the stock doubled in price, right? So this is not rational at all. And this is the kind of thing that I wouldn't apply AI to, or at least you at least have a human in the loop. All right. So I think if there are more questions, just in the interest of time and to be fair to the other speakers, let me stop now. Do connect, do try out the tool, and we'll keep in touch. Okay. Thank you so much. Hey, back to you, Nisha. Nisha or Bill, are you there? Or if as long as we are, if they're trying to get back, I can answer some other questions. I asked Gen Command to order pizza and the tool provided an answer. Okay, so Editon, the answer would be again the prompt that I've given. What you asked for, I include it into another prompt, right? So I will not respond to things like order a pizza, right? Or at best it would give you a curl command to do that, right? So I need to control what kind of questions that are asked. Okay, that is what is happening over here. All right. I will share my LinkedIn. Yes, I'll do that. Okay, this is me. And I think, Bill, you're back, so you can take back control. Yeah. Thank you for the opportunity, Bill, and thank you, everybody.
All right, great. Thanks, Vijay, for the great presentations. I know you probably still have some questions. Feel free to ask in the chat. Maybe he's still online to answer some questions, or you can reach him on the LinkedIn. And also for those links and resources, we're going to share it once after the event is done. All right, so let's move on to our next speaker. Let me just quickly share my screen.
Yeah, hi, can you hear me?
Oh, you're here. Okay. Yes, I can hear you.
Oh yeah, perfect. Let me quickly just just share my screen and everything.
Oh, did I give you permission yet?
Let me see.
Yeah, I think you can share.
Oh, it seems that I have to leave the meeting and join back in because there's some kind of security issue. I'll just do that. Give me a second. So sorry. Uh, can't do that really quickly.
Seems like we have some internet connection issues. I'm waiting for the speaker to reconnect. Just bear with me 1 minute.
Yeah, can you hear me? Hello? Hi, am I audible? Hello?
Yes, go ahead.
Perfect. That's perfect. Let me quickly just start my video. Uh, yeah, okay, that's that. And also, of course, share my screen. Uh, there we are. Okay, finally. Uh, Zoom was playing games with me, but now I'm good. Right.
That's great. Yeah, we can see your screen.
Yeah, yeah, perfect. Right. So, hello everyone. Good evening, good morning, or good afternoon to from wherever you are connecting today. My name is Suvaditya Mukherjee, and today I'm going to take you on a journey around how you can use Gemini and Gemma to accelerate your Golang application building experience. Uh, Quick bit about me. I am a GD in machine learning, specifically for TensorFlow Core and Keras. I'm also currently pursuing my master's in artificial intelligence at the University of Southern California in Los Angeles. I have been a part of a few companies before this as an ML intern, while I also write for PIM and such. If you ever come across computer vision blogs and the like, that's us. I'm also a co-organizer for GDG MAD over here in Mumbai, India, and I have also been a GDS lead during my university years, undergrad years rather. Uh, Also, in the little free time that I do have, I'm a Barcelona supporter. So if you're one, well, let's connect as well. Right. Some notes before we start. Well, engage during the talk. I understand that it may be difficult to unmute, but you can please feel free to drop your questions in the chat. Doubts are dangerous. If you have any doubts, please, of course, drop them in the chat again. Let me see if I can just open both of them together so I can answer questions side by side. Let me see. It seems I can do that. Oh yeah, perfect. Absolutely, I can do that. Thank God for two streams. I won't dive into too much math unless needed. Most of the things don't really need a lot of math in today's presentation. Slides and associated code will be made available, and after the talk, please feel free to ask any off-topic questions as well. So to begin, this is what we're going to be covering today. It's a longer talk, but I'm going to try and condense it as much as possible, just to make sure that we respect the time. Right. So let's start with the question: what is generative AI? Right. Many people have tons of different definitions for them, but one that fits a lot of different contexts is machine learning is the ability of computers to learn from data without being explicitly programmed. Now, the idea here is the fact that instead of giving some rules to process data to a computer, you basically reverse it and you give data and you ask the computer to create rules out of it. So that's normally a very interesting analogy that people put towards for machine learning, but the idea here stays the same, where you're learning from some data without actually telling the computer that, hey, how do I process this data? You ask it rather than tell the computer about it. Now, this definition, of course, was given by one of the more unique individuals among us, Gemini 1.5 Pro. That is a neural network, so I guess it knows what it's talking about. So, what is generative AI again? It's literally in the name. You can generate items of different modalities, be it text, video, audio, or anything of those types using generative AI. And it could include something like an LLM or a large language model for text. Or if you're into visual items like videos or images, it could be something like a latent diffusion model or the like. One of the examples of what you can generate is right there on the screen. All of these interesting GIFs or visual elements can be generated using current models that are available out there in the open source software community for machine learning, even today. But then it's very important to also understand the good uses versus the harmful uses. It's the same debate as data versus data. It depends. I mean, people just say it differently, right? The first thing that you need to consider in such a case is AI risk or X risk that people talk about. It's important to understand that generative AI has the ability to also bring in a lot of problems, while it also has a ton of potential towards betterment of society, right? So, for example, what you see on the screen, some business chatbots, portrait generation, summarizing information, all of these different tasks are good uses of it. It can help bring value to your enterprise customers. It can help you maybe draft an email to your professors about some kind of just pushing the assignment deadline, something of that sort. Or it can even help you answer some questions related to general knowledge. But then again, there are some bad uses like creating deepfakes, what you see on the screen in front of you, disinformation campaigns, and so much more. So it's very important to understand these risks and then make decisions on how you would like to use generative AI. So what are Gemini and Gemma? Well, Gemini and Gemma are large language models. As my previous speaker Sathish mentioned, they are basically just trying to mimic the next word. They are algorithms that regurgitate text. So you have neural networks that basically mimic a simplified representation of the brain, neurons rather, and you have tons of data that is collected or scraped out of the internet. Talk about forums, maybe just blogs, websites, YouTube, and the like. All of this is used, it's processed, and clearly inputted into this model, a neural network, and it is performed through something called pre-training. Pre-training is an idea which allows, which basically tells the model to train on this kind of data using GPUs. Of course, it's almost synonymous today that AI is just very much GPU intensive or compute intensive rather. So pre-training is that expensive step where you're taking all of these large scale data sets and you're pushing it into an LLM to basically train it. Once this training is done, normally these models are extremely good generalists. They can solve tons of different tasks across varied domains, but they are not as good as an expert, right? If you want to make them an expert, you can simply fine tune them on some smaller data. So that's the step that normally us as individual users can take. Let's look at Gemini. Gemini 1.5 Pro is a general problem-solving assistant. It's also what is called as a base model. These base models, especially Gemini 1.5 Pro, have a context length or how much information you can send to the model in one go. Gemini 1.5 Pro currently has the longest context length ever in a neural network model of a transformer scale. It's effectively up to 10 million tokens as seen in research, but currently available the current generally available model of Gemini 1.5 Pro has up to 1 million tokens in context, which is still far more than what you'd get on any other platform. It is multimodal in nature, so you have tons of different ways in which you can interact with the model, be it video, audio, code, text, and so on. Lastly, it's also very proficient at programming, as we're going to be seeing today. where it can work with Python, C++, and Go. But the undoubtedly less talked about model, the release that Google came around with, was Gemma. Gemma are a series of small and open LLMs that are meant for widespread use. Recreational or business users can directly take Gemma models and fine-tune them so that you can create something that is extremely specific to your use case. Using Gemma base, which is the base model similar to how Gemini 1.5 Pro is a base model, you can fine-tune it and get a ton of different tasks completed. But if you already are specifically focusing on code generation, or maybe something like visual language understanding, you can use the currently available fine-tunes out there for Gemma called PolyGemma and CodeGemma. Both of these models are already available, and they are meant to be fine-tuned further on the type of vision tasks or the code generation tasks that you're looking to perform. But the better section of Gemma models come out from something called recurrent Gemma, which is based on the Griffin model architecture, where it uses attention layers along with recurrent connections. So it just makes for an extremely good context length for something as small as the Gemma model. So that's about generative AI and how it works. But how does it help you as a beginner? It's important to understand that the market size for generative AI in just the first quarter of 2024 was $44.89 billion. That's all the companies, OpenAI and Mistral and all of these companies all coming together. That's the market size, right? You can increase your productivity at no cost to yourself using these models. So there are three main focuses of today's talk that I'm going to be making sure I demonstrate. First off is programming. Well, if you're new to programming, or you may be starting out with a new language, Gemini or generative AI equivalents for it can help you in charting out a path through which you can learn, or it can also help you solve some conceptual issues or problems that you may be facing while you start. It can also help you focus on certain topics more than others, which may be more specific to your use case. Let's say you're a network engineer, or maybe you're a backend engineer who's trying to work. Before you have that kind of knowledge about, let's say, Go, since Go is our topic of discussion today. If you want to work specifically on backend engineering, you want to focus more towards mitigating race conditions, working with network packages, and so on. Gemini can help chart that path out for you, which may not be available as well or as tailored to you on YouTube or other platforms. But then again, no programming journey is complete without facing errors. So when you are learning a new language and you see a very scary looking error, what do you do about it? At first, you normally go towards Stack Overflow, but now you can also use Gemini. You can just plop in your error along with your code into Gemini and ask it to debug it for you. Gemini is very adept at solving issues that are silent in nature, where where you may not be able to see any apparent errors right there, but Gemini can find it for you. But it also helps in creation. Once you've actually learned how to use a language or a program, it's also very helpful in being an assistant. Let it be a sidecar, or I don't want to say copilot always, but yeah, basically something of that sort, where it can help you build at a better speed than what you do generally using just normal programming, right? So now let's take an example. How would I, so disclaimer, I do not know Golang a lot, right? So when I started making this talk, I decided, okay, while I'm doing it, why not actually learn Golang from scratch, right? I asked Gemini, my first experiment learning Golang as a beginner. So coming to the first page, this is something that you'd see every day if you're using Gemini. Hello, Suvaditya, how can I help you today? I go and ask, how can I learn Golang from scratch? You give me a game plan for doing so, important topics I need to focus on, and where I could learn them from. So it gives me an entire list of things to do. First, of course, setting up your environment, because obviously, how can you run it if you're not, on your local machine? Of course, Go has techniques where you can use or execute Go code online and have it run on Golang servers. But it's just better to learn it locally, of course. You also need to grasp fundamentals. All of that can be done using the Go tool, which is a beautiful resource, by the way. Variables and data types, control flow, functions, all of these are standard day-to-day things that you are going to use if you're using Golang every day. So that's also there. Following that, you want to deepen now, or just dive into the more difficult parts, things about pointers, arrays, structures, data structures, algorithms, the standard library, and so on. And then you can always officially check out the resources, as you would be recommended to by Golang developers. Official documentation, there are some very good books around there, online courses, Code Academy, and so on. But of course, practice makes perfect. So it gives me some practice and projects to do. Go for sizes, as they call it, or starting small projects, maybe something like, just going around and solving XYZ, or maybe just making a dummy backend server. So it's important to make sure that you get all of those results at once, right? But this was just the game plan. How do I actually go about using the Gemini in that process? So I ask it, can you design some exercises in the form of questions and possible solutions that I can practice Go with? And it gives me some interesting questions that, any beginner would be happy to play with. First off, write a program that prints hello world to the console. That sounds pretty simple, right? Because, that's the first question that would come to your mind. That's it. Using Gemini obviously gave me the solution, but, I did some work myself. And I also wrote the code, and I was like, okay, that seems to be a very intuitive feedback loop where I can just go back and check. And if my code has some error, I can just put it back into Gemini and say, hey, for this question, I saw that my solution was not giving me the intended result. What do you think might be the error? And I might get the results back as to what went wrong in my code. There are 6 different such questions, right? You can look at the next question where rather Gemini asks, write a program that takes 2 numbers as input from the user and prints their sum. Again, pretty simple, right? So you get a solution. Again, I got it right at the first time. So, props to me, I guess. But if you are learning for the first time as well, you might find it very helpful to, have the solutions that you can refer to, and also get interesting code, interesting comments that explain what's going on in each of those lines. This is, of course, quite simple, but we are going to see that down the line. Next question, write a program that checks if a number is even or odd. Again, rather simple, you just mod by 2 and go on. This one's interesting, where you find the factorial of a number using a loop. Now, for the folks who do not have any experience with Golang, Golang does not have a while loop, so it only has for loops. So keeping that in mind, you can use for loops to obviously calculate the factorial and get a result. There's something like that. Again, write a program that defines a function to reverse a string. Again, rather simple. You define a function, you define rules, and go ahead and do write from scratch. The last question, write a program that uses a Go routine to print a message concurrently with the main program. Go is very famous for being an extremely good concurrent language to work with. So something like that, where you can execute a Go routine and get started with concurrency. That's it. Starting from that first question where we were at Hello World to actually getting to a place where you can create concurrent executions using something with simple Golang commands. That's what Gemini is helping you to do, charting the path from scratch, where you're learning if else, you're learning flow, you're learning control flow, you're learning functions, you're learning loops, and then finally you're stepping into concurrency as well. So that's that. That's the first experiment, and how you can get Gemini to learn Golang from scratch. But why should users adopt it, both in enterprise and both in personal use? First off, it's lightning fast. Gemini is among the best performance models out there in terms of latency. So if you're using it as a code assistant, maybe say in VS Code, it's not gonna be as delayed. It's gonna be very quick. Second, it's very easy to get onboarded onto. You just need a Google account. That's it. Fewer errors. Now, I know that this might be subjective, but Gemini tends to be better at code than most other LLMs available, and especially for something like Golang. It can help you to develop quicker while also giving you lesser error-prone code, while also checking your code and giving you possible hints as to where you may have made mistakes. It adapts to you. Let's say you're in an enterprise setting and you have some kind of code formatting, code linting, and so on. You want to make sure that you adhere to some standards. You can tell Gemini that, and it will make sure that while you also follow that, the code it generates also follows those same organization principles. But lastly, it's the most important part is the fact that it has centralized knowledge. If you're using Gemini for Google Cloud, Gemini will learn from the code that you write specifically for you, and it will be able enough to provide you context as to where you may be making mistakes or where you may improve your code based on the code that was written by maybe say a coworker of yours, right? It can access that kind of information across your organization and help you develop quicker and better. You won't have to go back to your internal forums or Stack Overflows and so on to again look up some error or look up something in your internal enterprise code. You can quickly use Gemini to reference it back for you. And lastly, fast prototyping. Gemini allows you to very quickly write some programs and just check whether something works or not, or whether it breaks things or not. So it's very good for code generation capabilities, as I've been talking about this entire time, but it can also help you build some extremely basic or building upon those basic things, some extremely interesting structures or functionalities that we're going to be seeing as well. Now let's move on to the second experiment. I talked about how well it's working in debugging, but let's see how it really does, right? So I want to show you how you can, debug silent issues using Gemini. Let's talk about the scenario. Let's say you have a Golang server, right? The server manages user sessions with a global variable. But now we have some occasional data inconsistencies, and we think that there might be a race condition that may have been introduced somewhere in our code. How do I, find it out? Because race conditions are normally rather interestingly difficult to find out. So there's a blob of code right now. I'm a beginner and I do not know what Go is. I just learned it 10 minutes back. How do I find the error? Well, I just put it into Gemini, and Gemini will tell me that, hey, there is something wrong in your code. But where? That's what Gemini goes on to tell me. The code that you saw uses a global user sessions map to store the user sessions. The handle login and handle logout functions, basically just utilize the map to perform the function. And two Go routines are running concurrently, one simulating login request and one going for logout requests. Both of them running concurrently, mind you. The solution will, again, as I said, throw it into Gemini. Here is some Go code, identify the issue, explain it to me, and give me the corrected code with the solution to the error. So when I give it the code, it tells me, hey, the issue with the code lies in concurrent access to the user sessions map. Go routines can run concurrently, meaning operations on the map by handle login and handle logout might happen simultaneously. This can lead to race conditions. It also tells me what a race condition means and what a global variable means. And then it gives me a solution. How can we fix this? Using a mutex. Mutex variables allow you to do that. It's something related to race conditions again. So again, I said I'm a beginner, right? So when I'm a beginner, I do not understand. I just need the code and make my manager happy. So I take the code and I put it back in. But what do I see are the changes? Well, I want to focus somewhere over here where it's defining a mutex variable, mutex for synchronization. And it also imports sync, which basically locks and unlocks the mutex based on the order of the requests that come in and out, so that the global variable is accessed only once at a time. It's not accessed together at the same time, and not the same thing is being changed by both of the functions again and again and again over time. So that's that. It corrected the code for me, and it gave me the entire thing at once. What changed? We added a sync mutex variable named mutex. Both handle login and handle logout now acquire the mutex lock before it makes the changes. And the defer statement ensures that the mutex is unlocked. Even, there might be some error. Again, backend servers, they are very prone to errors if you're not in a resilient environment and so on. So yeah, the Go routines will now be much better at handling these problems, and your race condition is no more thanks to your mutex. So that was a simple example of how you can debug Golang applications or subroutines using Gemini. But now, why should experts use Gemini? Let's say you are a seasoned Golang developer. Why should you be using Gemini? Well, it's basically secret sauce for you. You can perform optimizations on your code because it'll analyze your code and tell you where you can make some improvements. Or it'll identify bottlenecks, as we just saw with the race condition, and tell you how you can improve it. It can also identify data patterns of how you're creating or deleting your variables if you're working in that difficult an environment, and tell you how you can make sure that you adhere to the best practices. Security auditing. Many people, obviously, if you're working with backends, you want to make sure that your system is as secure as possible. Gemini will allow you to perform that kind of auditing. It'll look at your Golang code, tell you about any possible security vulnerabilities or issues, maybe some kind of a way wherein a threat actor may find some way to, step into your server or something of that sort. And lastly, for rapid prototyping, as I mentioned, Gemini allows you to quickly write components and check out for things. So if you're looking to, develop something from scratch very quickly, Gemini is your best friend. Now let's talk about that. How do you actually build out components using Golang, or rather optimize them as well? Creating new applications from scratch using Gemini. Let's talk about the scenario. It's very simple. I thought of it because since I come from a machine learning standpoint, I thought, okay, hey, what if there was a Golang library that allows users to, just work with Python functions right from scratch? So I tell Gemini, hey, write a Golang library that helps general users to deploy Python functions through Go. Write each file and a small explanation of how it works at each step or file. Well, at first, it tells me, hey, that's very simple. This is a basic Golang library that allows users to deploy Python functions. It will basically just execute the function for you through the terminal and just assumes that the Python interpreter is available on the system. So if you see the code, it seems rather hacky at first, but it works, right? This is deployed at Go. What it's going to do is basically take the function that you write. Let's say you write def add a comma b, and you basically just return a plus b, which is going to sum up two numbers or two variables for you. Well, first it's going to create a temporary file for you, followed by actually writing that Python code to the temporary file. executing the Python file, capturing the output, and returning that to you. So it basically acts as a wrapper on Python using this. So does that. It, as I said, it creates the temporary file, writes the code, builds the command, and so on. Now, utils.go is another file it created where it's basically just validating the function and telling, okay, hey, is this function even valid or not? Underlying, it's going to take the string and it's going to check if it's JSON or not. You need to pass in a JSON, which will, just be quicker for Go to process with or work with. And then we send it in. This is an example code that Gemini again gave me, telling how I can actually get started with using that little library of mine. So I import deploy, I write the Python function and send it in as a JSON, and then I quite literally just get an output. So I get 2 plus 2 comma 3 is 5. So that example just tells you, right, how you can define a Python function, you can deploy it using this function and get the output. Now, an interesting way to build upon it is to allow it to accept these Python files using maybe a backend server of yours, right? Maybe just ask Gemini, hey, can you write a backend server for me that would deploy this function on a web server or allow people to send requests in the form of Python strings, Python programs that are represented as strings in a JSON, and process it and send it back, right? Just to make like a Python execution engine. This is a basic example, and it just shows you how easy it is to build upon these things. For example, this library that you just saw, I made it within maybe 5 minutes at best, or maybe even lesser if you just gonna take away the time it took me to understand what was going on, right? So this is a basic example, and it can be extended on to handle much more complex scenarios. Security considerations are obviously not included in this example, but Gemini, if asked for, can do so as well. So yeah, that's that. That was me. That was mainly what I was here to cover around. I hope I could give you an overview of Gemini and Gemma, and especially how it's helpful as a code assistant, and how you can get started with using Gemini and Gemma for your code escapades. Yeah, that's me. Thank you very much, and feel free to connect with me. This is my Twitter ID. You can just reach out to me there. The slides for today are available here. There is not much associated code. Whatever is already available or linked through the slides, so feel free to use that. If you're learning Golang, please look at the tour of Go. It's a very beautiful resource. Highly recommend it. I'm learning through it myself. It's been an interesting journey, but yeah, absolutely. Good day to all of you. Thank you. And I'll just hand it over to the host back.
Thank you, Suvaditya, for your insightful session. So before we wrap up, once again, is my screen visible to you all?
Yes.
All right. So before we wrap up, I request you all to please scan this QR code to share your thoughts. Your feedback would be really helpful for us to improve and focus on what's important for our next session. It will hardly take 1 minute to complete the feedback form. And thank you all. Thank you for joining this session. I hope everybody has got some insights from both the speakers. And our next session will be on 22nd June. I hope to see you all again soon.